Hello guys, Vilash, Selva, all well? Am I audible?
Yes, yes.
Yeah, thank you, Vilash. So, sorry guys for the last time. Actually, it was a kind of emergency happened. So, I was not able to join at that time. So, no worries. We shall start latest by today. And we are going to cover the probability from the classes of the dependent events and rest assured. Hi, Selva. How's the life? How's the learning going on? Yeah, Selva, you may unmute yourself and speak up. Sobin, how are you?
Hello, sir.
Yeah, fine, sir.
Great.
Hello.
Yeah, Selva, please speak up.
Hi, sir. How are you, sir?
Yeah, I'm good. You tell about yourself. How's the learning going?
Yes, yes, going well, sir. How are you, sir?
Great. Yeah, it's good
Sir,
that I find you guys to be learning well and quite motivated to learn new things in life. So let's wait for a couple of minutes. Let the all of your peers may join, and then we shall start.
okay.
Okay, Vilash and others.
Okay,
Selva.
sir. Okay, sir.
Okay,
My
okay.
my video is
Okay.
clear for you, sir.
No,
Yes.
Selva, you are not visible. Only a image is coming.
Yeah, I know. I will check the settings for the
Yeah,
issues.
yeah. In
Okay,
that
sir. Okay,
case,
okay.
if you could give your device permission to join, or you may rejoin.
Okay, sir. Okay, okay. I need to rejoin. Huh? Okay, sir.
Yes,
I will go
yes.
rejoin. Sir.
Yeah.
Okay.
It's okay, Selva. Actually, there might be certain computer glitch or internet glitch, and these
Yes, sir.
type of glitches are usually associated with the network. Okay, so it happens sometimes. And even sometimes, say what happens is suppose if I'm driving the car and when I
Yes, sir.
need my back gear, to be in synchronism with my back camera, at the very same
Yeah.
time it do not work well.
Okay, sir. Okay, 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 sir.
So
Okay. Okay.
so most of the time it happens.
Yes, sir. Yes, sir.
Okay. So let me share my screen and do let me know whether the things are visible or not. Hi Sayed, how's the things going on?
Yeah, good, sir.
Uh, Doing great in life.
Canadian study.
Okay, so I'm sharing my screen. Athira, could you enable me to share my screen? Thank you. So let me make it a full screen. Come to here, going back to the Zoom. Now I think I can go for that. 1 second. Oh, hope it is visible, guys.
Yes, yes.
Yes.
Yeah, thank you. So let me recapitulate what we have done so far because it's been around 2 weeks. So just hold your breaths. So I believe we had covered the probability, and we had seen that how to check the probability, because it is all about the likelihoodness and the, what may I call it, chances or the opportunities to be grabbed upon. So hereby we had learned that what are the independent events. It's as similar as whatever happens, these independent events will never change. Like if you are standing on the South Pole or the North Pole, irrespective of the location of your position, whether you toss a coin or you do anything else, the position of head and tail do not change. Yes or no? So that's why we call it independent events. That is one thing we had covered so far. And we learned that how in any circumstances we uh, toss a coin and we see that, okay, these independent probabilities are 0.5 irrespective of the temperature, pressure, location, or any other condition. Therefrom, we had seen that how the this chart of probability is working for us. Whenever we say something impossible, like if I say, "Are you going to live for 500 years on this earth?" You will say, "No, not at all, impossible." So zero likelihoodness. Hence, we call it probability of 0%. And sometimes we say, "Okay, what's the probability that you get? What's the higher probability that you get 4 if you toss a dice or if you roll a dice?" So it's quite unlikely. That's okay. There is only 1 out of 6 chances, hardly 12%. Similarly, if you are tossing a coin, there are even chances. And if you have to fetch 4 blue balls out of the 5 balls in which four are blue, there are extremely higher chances, and so on. So likewise, we had seen that how the scale of probability works. Therefrom, we had looked for when more than 2 events comes together, we go for multiplying those events only and only when those events are independent in nature, my dear. Independent in nature. The independence is very much important. Here also we had seen that if you toss a coin, you have the probability of 0.5, but if you toss 2 coins altogether, and oh, sorry, I won't say altogether, I would say in a alternate, that you tossed a coin and again you tossed a coin, then you are getting every time head is having a lesser probability, and you are getting 3 times head in a row, it's a very less probability. So provided we multiply the probabilities only and only when we are having such independent events. And this we had learned in a mutually exclusive event, if you remember from our previous discussions about the probability. And here we had seen that, yes, how if we want to get 7 heads in a row, so this is the, you multiply every independent probability 7 times and you get where even a lesser than 1% chances are there to receive the same. So these are the examples we had covered. I'm not going to repeat them up. So these are the things. Hope you are remembering that we had covered these examples. Any doubt in this, you may ask now. Else, with your permission, we can move ahead. You may see that, yeah, hereby we are having dependent and independent event. Do you remember this curve, this particular slide? We had seen that, yes, how the replacement works. So when you replace something, it becomes a dependent event. When you do not replace anything, it becomes a dependent event. So there are only situation when you had done some event and you redo it. Hope you remember your command in Windows. You do Control Z, Control Y. So when we do undo, we say replace it from the previous content. Yes. So that is a dependent event. Sorry, that is an independent event. Means whenever we are doing Control Z, it's an independent event. Whenever you are not doing Control Z and you are just keep on adding the things like anything, you are actually making the things as an dependent. Hope I make sense as per your daily activities. So hereby we will continue this example in order to understand that what are the dependent event and how they are exactly. And mind it, this would be our Abdauji, please mute yourself. Abdauji, Abdauji, please mute yourself. Thank you. So this is one of the slide where we had seen that what are the dependent events, but event are said to be dependent, which means they can be affected by the previous event. So hereby it says, let's say we have marbles in our bag and 2 blue and 3 red marbles are available in front of you. So what are the chances of getting a blue marble? Simple. You take the bag and you take one out. So it becomes 1 out of here. 2 marbles are there, but you have to pick 2 blue. Means what are the chances to pick marble? Now the condition is that how the question is being asked. Mind it, how the questions are being asked. If they say you have to fetch 2 marble at a time. See, there are 2 types of question. One is you are fetching 2 marble at a time. Then the only probability is 2 by 5. Am I understood? Let me write it for you. Let me choose a proper color. Say, I'm saying here from you have to choose 2 marbles all together. All together. Okay. So you have no choice. You have to pick 2 marbles from the bag. So how many marbles are there? 2 marbles are there out of 5. So you will say, okay, you are picking the 2 and from the sample space. Mind it, we divide the thing by the sample space. Sample space consists of 5 marbles. So 2 of 5 is the straight answer, mind it, my dear. So hence the probability is 2 by 5, or you call it a 0.4. And if you consider it and convert it to a percentage, you call it a 40%. There is a 40% chances that you get 2 marbles, and out of those 2 marbles, you are getting a blue marble. But again, if I change a question, I ask, you had this one, and first you took 2 marble. Sorry, first you took 1 marble out of this bag. So what's the probability that you get the blue marble? So you simply take, you simply have the probability 2 by 5, because there are 2 marbles in this, and you are fetching only marble, 1 marble. So there are 2, what is that? Blue, and total 3 red, and in total they are 5. So 2 by 5. And if I say now you are fetching again, and you have to fetch blue marble only. So again, hereby you will draw, this is a blue marble and rest of the 3 are red marble, and hereby the probability becomes 1 out of 4. Are you able to find the difference between the two? Guys, Abhilashji, Abdauji, yes or no?
I don't get you clear.
No,
Can you
So here,
no, sir,
start
no.
again?
yeah. Okay, Selva. Let me repeat. Say if I say, mind it, let me remove this. Okay, let me write this particular thing hereby. Here, you had smaller one, small marble and the big marble. Okay, consider this example. And
Okay.
if I ask you, you have to pick, you have to only pick 2 marbles. Okay, whatever it comes, it's not the problem. So you have to pick 2 marble from this bag, and what is the probability that you get blue marble? Simple question. So you say, okay, I have to pick 2 marble, and okay, let me pick 2 marble. So you pick the 2 marble, it's okay, fine. But how many marbles were there? And even you had 2 marbles for smaller one as well.
2.
So see, these are the smaller one.
Okay.
And you were being asked that what are the chances to that you get the smaller marble. So there are only 2 smaller marbles, so there won't be more than 100% chances. So you consider that, okay, out of 5 marble, I'll be picking 2 marble, and I am 100% sure that I'll be getting 2 smaller ones. Okay, if you are not manipulative and making a whirling statement inside the marble bag. And you from the sample space, what was the sample space? Total 5. Selva,
5.
isn't it? Total
Yeah.
5. So
Yeah.
hereby when you picked two marble, whatever be the two marble, say you might have picked the bigger one as well, but the probability says that collect the total number of possible outcome divided by the sample space. So total
Okay.
possible outcomes were 2. These smaller were 2. Yes or no?
Yeah.
You were also being asked to only take 2. So 2 out of 5 is the only answer, mind it. But now if I ask here at Silva, please pick one marble and one marble. What is the probability that you are picking the smaller one? So you will say, okay, sir, I am picking the one smaller marble and I am having, see, this is a separate question. This is the first instance of our discussion. Now this is the second instance. Secondly, we
Okay.
say, okay, the
3 by
marble is
4.
full. Yeah. So, no. Just have a look. Have a look here. So here we say, okay, you have to pick one marble out of it. And how many marbles are there as a smaller one? So you will say, okay, there are 2 marbles are there. So I'll be picking 2 out of 5 in the first instance. The probability is 40% that I'll pick this marble, mind it. But if I say now again pick one more marble, so this was the probability. This was not the number of marble. This was the probability. Now you are only left with the first one. You are only left with one smaller and the 3 bigger. Now if I ask you again pick the smaller marble, what would be the probability? So how many are there?
1 by
is
4.
one only left.
1 by 4.
1 out of total is 4. Very good. So this would become the total probability. Now the event says that multiply them. If you are going to multiply them, so you are going to multiply 2 by 5 into 1 by 4. So this comes out to be, say, 1 by 10. So this becomes 0.1 or simple 10%. There's a 10% probability, but here was the probability as a 40%. Why is it so? Could anybody explain me? Let me make you here available. Yes, Avilas. Would you be able to explain, or anybody else, Selva, Fazil, Abdauji, why is it so that we only, when we picked one marble at a time, 2 marble at a time, we had a 40% chances, but when we are picking one by one, the chances are decreasing? Yes.
Total number of marble 5 number. Instead 5 number against we took 2 number. That means 40%. No?
Yeah, I'm listening. So
Out of 5 from we taken 2. So out of 4 from we taken 1. That is coming. That's what is the difference.
okay, great. Give me one common sense answer. One very common sense.
Very good.
The lower the
Suppose.
number, the lower
Yeah,
the
Abdauji,
percentage.
please repeat. Abdauji, please repeat.
Seems like the lower the number, the lower the percentage we are getting.
That was the question, Abdauji, that why I'm getting a 10% here and 40% here.
The more we are decreasing
See,
in number,
yeah, that is fine. That is a logical thing. But see, if you notice, say suppose you are having a one number 2 by 5 at your first instance. And if I multiply it by 1, does it get affected?
Nothing.
Nothing. But mind it, I am multiplying this by another fraction. Mind it, I am multiplying it with another fraction.
1 by 4. Correct.
1 by 4. So one fraction multiplied by another fraction is decreasing itself. Like you have so many percentages. Say suppose you have so many percentage, 90%, 80%, 70%. But when I multiply all of those percentages, this becomes 9 8 56 into 7, around 7 6 42, around 39% around. So when you multiply the percentages or the fractions, the total answer is lesser than that of the lowest one.
Okay.
Is this
Right.
understood and digested well?
Yeah.
Yes. Now got it.
Thank you. So always be mindful, try to think why this has happened and what was the thought process, because we have not started something out of the blue and discussing like anything. We know the fundamentals, and always observe that whether the person who is writing in front of you or dictating in front of you is he or she is following the mathematical guidelines or not. That's the first thing. Then let us move to the another slide. That is our today's discussion. We call it a conditional probability. Conditional, see, till the time we had studied the probability. Again, the probability says I am the likelihood, I am the chances, and I am the, say, prediction. No, I won't say prediction. Let's stick to chances and the likelihoodness. Whereby when we give the quantitative term to them, when we add a quantity to them, or when we add a quantitative ability to them, likelihoodness or the chances or opportunity, we say it a mathematical term as a probability. But we had added an adjective to it. This is an adjective. See, if you are having a verb, if you are having a noun, if you are having anything, and some word is adding before it, and that word is actually not, I must say, exactly changing the overall meaning, but it is changing the even the partial meaning of the same. Consider that as an adjective. Like if I say you are good, and now if I ask somebody else like you are very good, so that good will be offended a bit. Okay, so very has actually been an adjective to the good. So hereby this conditional is an adjective which says now the probability will be applied over certain conditions. And mind it, we are now going to start this as a dependent event. So these dependent events, let me admit him, these dependent events are actually the conditions. They are actually the conditions, because you must have seen when one marble was taken out, the whole sample space changed, the whole scenario got changed. So as the conditions are changing, so does the outcomes. And believe it or no, this is the real truth, or you may call it as a ground reality. You may call it as a ground reality. So if they are the ground reality, it's better to understand them, apply them, and look via the glasses of these conditions. So what is that? It says it is the likelihoodness of the event occurring given that, see, this term is very important, given that another event has already occurred. Like if you say, like three friends are going in a party, and one of the friend is saying, okay, if that friend comes, then only I'll be able to join that particular party. So you have objected, or must I say, you have projected the particular friend as an event, that okay, if this friend arrives, if this friend comes or arrives, then only I'll be able to join the party, else no, not possible. So hence we call it, this friend has situated at the center of the point and considered himself or herself as a conditional event. Like if you say, okay, if there is a curd today, I'll be able to have the food. Simple. There are few people who are not able to eat the food without the water. So if they are having a water, then only they will be able to digest the food. And even they can only think of having the food after the water is received. You might have seen that situation in life. So such things are called conditional probability. Now from your workspace, would you be able to remind me or recall few of the conditional probability? Abhilash, you may start. Unmute yourself. Unmute.
Sorry. Actually, what I have to tell actually?
You have to tell where did you
Yes.
find the conditional probability in your workspace, your life events. Conditional probability.
Conditional format. I have to go work.
See, I must say, you will be doing something provided something has happened. Like, let me give you an example. You will only carry an umbrella when you find the rain outside.
Yes, correct.
So likewise, please elaborate few of the conditional probability. That what are the conditions you have decided for yourself in upcoming life or in so far life, that yes, these are the things happened, now I'll be doing that. It can be anything. It's okay. You may share it. I would like to
No,
allow
okay.
you to think like that.
Okay, like if I'm preparing the food, I can eat.
Okay, only you only eat when you prepare the food.
Yeah, because I am alone.
Oh, great. Suppose if in a certain situation you are not able to prepare the food, you have to come or go to outside canteen.
Yeah, I'm going to outside a hotel.
Okay, okay. Abdauji, Fazil, Selva, your contribution. Anybody
Yes,
who
sir.
would like to say? Yeah,
I would
Fazil,
say like
please.
I will attend the utility congress if I have a pass.
See. He's not going to spend the money. He will only attend that when he's having a pass. Very good, Fazil. It's a very good exam. Yeah. Anybody would like to share out of the 14 participants today? Yeah, somebody joined. Selva, any thought to discuss? Abdauji, Sayyid Sabir, Kunal, Prakash, Manu Matthew, Sanesh. Sanesh, you are there. You are not participating. What happened? Hey, Gary, you joined twice. Asif, Sanesh. Okay. By the time, if you think something, you may message me. Let me move ahead toward the
Yes, sir.
discussion. Okay. So this given is very much important, my dear. If you find somewhere in a probability that you have to decide some event, given something has happened or given something is going to happen, please think about conditional probability. Then it is notation says that how to indicate them. So we denote conditional probability as PA/B, probability of event A given the event B has occurred. This is the meaning. So A means event A, this slash means given, and B means again event B. Is it clear?
Once
Like,
again,
yeah, let me repeat. Like Selva or no, Fazil said that he will only join the concert when he is having a pass. So joining a concert would be event A. Event A would be a concert. Event A would be a concert. Event B is a pass. So provided there is a pass with the fuzzle, then only he will be joining the concert. So are you able to understand that what is the meaning
Yeah.
of A and B here?
yes,
Yeah,
yes.
great.
Yeah, got it.
Thank you. Thank you. So to calculate probability of A given B, we use the formula which is denoted as probability of A given B equals to probability of A and B. Mind you, it is a single probability. A and B happening all together. Divided by probability of already happened event. This is what this particular line is indicating all about. So we shall remember this formula and try to solve certain questions in order to understand the conditional probability latest by today. Okay. So here is the tree diagram that is being drawn in front of you. So which simply says, as we had already discussed, that yes, there are these many marbles. If you take two marbles at a time, if you are taking a marble at a time, there's a probability that you are having 2 by 5. But if you are taking a red marble, you are saying I'm having a 3 over 5 as a probability. But the real picture starts after the first marble is taken from. So till this point, nothing has changed. Let me change the color. So till this point, nothing has changed. But now after this, if I ask, at this situation, what would be the probability that you are drawing the blue marble? So again, as we discussed, it is only 1 out of the total 4. So you will simply say that you are going to simply multiply these two probability in the tree diagram. Okay. But at the same time, if you say, no, I don't want the blue marble, now I want the red marble, then what is to be done? Be there, stay over the place and think that, okay, how many red marbles are there? You observe that there are 3 red marbles, and out of total 4, so you simply says, okay, pick the one, and probability of getting any red marble is 3 out of the total sample space, and sample space is 4 because there are total at this moment. So I'm saying this moment you are having 4 as a sample space, and at this moment you are having 5 as a sample space. Yes or no? Are you okay at this point or no? This is the play of a sample space. Abhilash, guys.
Yes.
Yeah. So always try to think that where the sample space is changing. So if you have been asked that first you pick the blue marble, then you pick the red marble, what is the total probability? Then you will simply say, for the first one, if you pick blue marble one after the other, you will say 2 by 5 multiplied by 1 by 4, it would be the final probability. But if somebody asked, if you pick the blue marble, then you pick the red marble, then both of the time the sample space is changing, you will simply say 2 by 5 multiplied by 3 by 4 would be the probability that you first pick the blue and then you pick the red. Similarly, if you say, now at the first moment, you now pick the red marble. So after picking the red marble, the total count is already same. That's okay. The sample space is same. Say you say this sample space is S, this sample space is S1, and this sample space is S2. So at this moment, S1 is equal to S2, which is equals to 4. But there are 2 red here, but there are 3 red here. Yes. So
Yes.
these S1 and S2 are equal in count. Okay. They are equal in count, but not in characteristics. There are 4 marbles. Okay, that's fine. But the nature of the marbles are different. So now you would say that at this moment, let me change the color for you. Yeah, at this moment, you would say that I have drawn 1 red marble. So the probability was 3 by 5, this one. And then you draw the blue marble, the probability is 2 by 4, this one. At the second time, you drawn the first as a red, 3 by 5, it's okay, multiplied by 2 by 4, because it's only 2 red marbles are left behind. Okay, so see how they have become a similar thing. So at this moment, 3 to a 6 by 20 and 6 by 20. So at this moment, you consider it as 2 3 a 6, 2 10. So this is a 30%. 30%. Here you have 10%. Here you have again 3 by 10, 30%. So see, changing the sample space or changing the event, say suppose if there would have been 3 balls, 3 colored balls, then a different kind of entity would have formed. So are you able to follow the tree diagram, that whatever is being asked, start from the main sample space, then extend it, create the another sample space there itself, and then again extend them, again create the sample space again, and then extend them. It is like expanding the tree unless until the bag is empty. Unless until the bag is empty. Yes or no?
Yes.
Thank you. So moving ahead, now the question is in front of your screen, which says, now we would like to answer a question like, what are the chances of drawing two blue marbles? Chances of drawing two blue marbles, we already learned it that yes, but see how elaborated this screen is like this. First, you are drawing a blue marble, again you are drawing a blue marble, and drawing a two blue marble is this. If I ask you at this moment, what is the probability of drawing a two red marble? Please answer me the question. You are having 60 seconds for it. 60 seconds. Selva, Fazil, Prasadji, Sayyed, Sanesh, Asif, Manu Matthew, Muzammil, Garis, Sobin. Please answer.
%30.
The question is, what is the probability or what are the chances of drawing two red marbles? See, I have shown you for the blue. Give me the answer for the red.
30%.
How much? Fazil?
30.
30. Okay. Fazil said 30%. Let me mark his answer. How did you get that to the answer, Fazil?
3/5 into 2/4.
Very good. You said 3/5. First you drawn the red and again you drawn the red. Great.
Yeah.
Now, at this moment, if I add one more blue here, okay, I'm adding, consider this as a blue. Consider this as a blue. Now I'm asking you the question. 30% is correct. See, it's simple. You have to take one red, another red, multiply them, and the answer is in front of you. 3/5 into 2/4.
2/4.
Simple. 3/10, 30%. Simple. Great. But now I'm asking, you are having three blue balls from this moment. Three blue balls. I have added it. Mind it. I have added one extra ball at this moment of time. Now I'm asking you the question that what is the probability of having first red ball and second blue ball? Answer me here. Consider this blue is added at this moment here. Question is understood?
So you added one blue balls.
Yes, here I added blue ball here.
Yes.
This answer is actually not in front of your
50%.
screen. Okay, somebody said 50%. Okay, let me
50%.
mark the answer. Okay, it says 50%. Anybody else who answered 50%?
Selva. Yes, sir.
Selva. Okay, Selva. Selva said 50%. So let me write his name. Selva answered 50%. Anybody else? Abhilash, Sanesh,
Yes.
No, I
Prakash
got
ji,
something different. 24.
24. Somebody said 24%.
Yeah.
Okay, 24. Is there anyone with another voting option? And here voting is blank. You have no option in front of you. See, try to calculate like this. Here, Till this point, no problem, because one red ball has already been taken. So you have to only multiply 3 by 5. But with whom to multiply 3 by 5? So here you had 5 balls in total, and you are drawing blue at the second time. So this probability 2 by 4 will change as, because see, now there are 3 blue balls at this moment, 3 blue balls. So this changes to 3 by 5. Simple. Yes or no?
Yes, 3 by 5. Correct.
Simple. 3 by 5. So you multiply 3 by 5 into 3 by 5. So answer is how much?
36.
50%?
Sorry, 36, right?
Yeah. 3 3 are 9.
Yeah.
5 5 are 25.
25. Yeah, 26.
Multiplied by 100. 36%. So nobody
Yeah.
answered a correct answer.
That's fine.
See, sometimes what happens, Fazil, we see two values and we hit the 50% button. Yes or no? We see two things and we hit 50% without calculating it. So that is
instead
always.
of 3 multiplied by 3, I suddenly added it by mistake.
Oh. So always try to solve with the, say, easy. Be at ease. Think like, okay, I have been asked like adding a blue ball here, and after adding the blue ball, actually the sample space turned into blue, blue, and blue, red, red. This is the sample space, my dear. Hereby, if you are again fetching a blue ball, so this is 3 blue balls are there. How many? Out of 5. So 3 by 5. Simple. Hope the question and the interpretation and the brainstorming got understood. Thank you.
Yes.
Yeah. So here are the notation which we have already covered, that what do we mean by that. So here it has been given one thing, that what is here mean by event A and event B. So this says we already know that PA means the probability of event A, PB means the probability of event B. But in our marble example, event A is to get a blue marble first. Mind it. The first term is very much important. So when we say that something has happened, so this has happened already. So now you are going to check for something else. So this would be the first event. So blue marble first means this should be the, must I say, given event, or already occurred event. So hereby, simply you got probability of having the blue marble is 2 by 5. And then we say red marble, get a blue marble second is the event B. So when you've been asked that what are the probability that you are fetching 2 blue marbles, one after the other, mind it, not all together, one after the other. It means first blue marble, blue occurred. So this becomes a given event. And then again you are asking, again pick a blue, which is to be asked. This is the asked event. And there is not a, may I say, necessity in this certain type of conditional probability that the event B and event BA are not necessarily different. They can belong to the same event, but at certain other time. Is this understood? You are drawing 2 blue marbles, but one after the other. You are drawing 2 red marbles, one after the other. You might draw 1 blue, 1 red. So blue becomes first, red becomes second. You may draw first red, then blue. Then red becomes first and blue becomes second. Likewise. So vice versa. So always remember what is the given event and what is the asked event. Should I move ahead?
Yes.
Thank you. So I think no need to explain this. This is already understood. Here is the question. So drawing 2 kings from a deck. Deck means the cards, 52 cards. So here a deck means a set of 52 cards. So from the 52 cards, how many kings are there? All of you know there are 4 kings
Four.
in the
Four.
52 card. Great. So
Mm.
if you are drawing first time, see now the sample space is 52 cards. And the probability of drawing a king,
4.
probability of drawing a king, mind it, I have written a king, means one king, is how many kings are there? 4 kings
4.
out of 52. So this is what it is indicating, my dear. So drawing a king from the total deck of set of deck is actually 4, means 4 by 52. Now, sooner you have drawn it, how many kings are left?
3.
Very good. 3 kings are left. If 3 kings are left, it means now the sample space has also been decreased.
Yeah.
So here the sample space will now becomes 51 cards.
Oh, 1. Correct. 3 by 4. Okay.
And probability of again drawing a king,
Mm.
again drawing a king, but here is happening when one has already happened, provided a king is already drawn.
Correct.
Already drawn
Drawn.
is actually 3 by 51. This is the meaning of probability of B given A. Am I well understood? No?
Yeah.
All of you, Fazil, Abhilash,
Yeah.
Sanesh, thank you.
Yeah, yeah.
So at this moment, if you have been asked what is the probability that you are drawing 2 kings from a deck, is actually they are asking you, you have drawn a king, and again what is the probability that you get a king again? So see, I am shuffling a deck, and out of the deck first card is king. Okay, great. The probability was 4 by 52, means 1 by 13. And
1 by 30.
yeah, and again the next probability is, again I shuffle it and I get a king. Again the probability is definitely 1 by what is that, 1 by 13, but it would have been 1 by 13 when they were independent event. Okay, but they are now dependent. So now their probability would be 3 by 51, which we call, I think, 1 by 17. So we will be multiplying them, probability of A and B, and see where from this formula has come. Will anybody be able to find it? Why such a formula is written? Where from this has come? Had we learned it today?
Yeah, on the conditional.
Very good. We had learned it from B by A, P A and B divided by what? A. Why A? Because given is A, hence divided by probability of A. So if I have to find the probability of getting 2 decks, means, sorry, 2 kings. So A is also a king, B is also a king, but conditional event. So you will simply, first, this is a very independent event, probability of getting a king from a deck, very independent event because the sample space is not yet touched. So 4 by 52. So this is having the probability of 4 by 52. And this PB by A is actually given, mind it. This is actually given that the probability of having a king, that already a king has been drawn before, is this. And this is 3 by 51. And when you multiply both of them, you will get this answer. And the answer is hardly 0.5%. So less. Do I make sense or no?
Okay.
Okay. So hereby, this is how to understand these things. So now try to see that this is like finding the hidden data. So see, this such a beautiful question is being drawn in front of you. It says 70% of your friends like chocolate. Simply frame it in terms of probability. So you will say the probability that my friends like chocolate is 0.7, correct?
Yeah, 0.7.
And 35% like chocolate and strawberry. Again, see the term and has come. So this is probability that my friends who likes chocolate and strawberry is actually how much? 35%, 0.35.
0.35.
Now the question is very tricky. What percent of those who like chocolate also like strawberry? You might get buffered. You might go for probability of chocolate given strawberry. See, you might think like this, but see again, read the question. It says, what percent of those who already like chocolate also like strawberry? Means we already have the data about the friend who like the chocolate, that is 70%. So it is been asking, what are the percentage of your friend that, okay, that who like the chocolate also like the strawberry? They might or they might not. So we have one common data that is 0.35% that they both like chocolate and strawberry. So, and see, this data says that those who like strawberry also like chocolate, but we have not asked here. We have been asked something else. We have been asked that what percent of those who like the chocolate also like the strawberry. Means find the probability of your friends who might like strawberry, but provided they like chocolate. Am I understood? Like, say you have uh, invited the friends, and you know that you are having say 20 friends, and all of them like chocolate. So you definitely purchased 20 chocolates. That is for sure, because you know all of them like chocolate, but you do not know that how many of them like strawberry. So how many strawberries are you going to order? This is the question. Am I understood by my question?
Yeah, question understand.
Yeah. So here you have to order the strawberry only for the people who like the chocolate. So this is the question which says, okay, you have the data that 70% of your friend who like the chocolate, like the strawberry both. You have the data that what are the people who like the only chocolate, and so you would be only ordering 10 strawberries because you calculated that there are only 50% of my friends who like the chocolate also like the strawberry. Does this question help you understand that what amount of order to be placed in your birthday or not? See, you have to solve it yourself. Then only it will be digested well. Am I understood or no?
You understand?
Okay. All of you, let me ask others. Selva, Fazil, Abdauji, Prasad,
Yeah.
Yes, sir.
Muzammil. Yeah, thank you. So I'll be sharing this slide with Athira, and she will be forwarding it to you. And latest by, I think, within 24 hours, this will be live in YouTube. So no worries. Here we go. So see, this is a big example, and I'm going to only explain the example. You have to find the solution to it. Again, a big example. It will take again 15 minutes of your time in order to uh, consider this example. So see, there's a saucer game. People are playing the footballs, and saucer game says that you are off to saucer and want to be the goalkeeper. You are a die-hard fan, and today you want to be a goalkeeper, but that depends on the coach. Who is the coach today? So this says there are two coaches. One is Sam, another is Alex. So with coach as a Sam, the probability of being a goalkeeper is 0.5, 50%. 50% chances are that you become a goalkeeper if Sam is the coach. But if Alex is the coach, what are the chances that you become a goalkeeper is only 30%. My God. So 30% are the chances. So we will say Sam is the coach more often. This is the normal thing which has been found, that usually, okay, Sam becomes the coach, and if your luck favors, you might get the Sam. So about 6 out of 10 games, Sam is the coach. So we say Sam becomes the coach 60%. Okay, see, this is the different probability. This probability was that you become a goalkeeper when Sam is a coach. And this is the probability that what are the probability that the Sam become a coach. So what would be the probability that Alex become a coach? Anybody?
Alex, 30%, 30%.
40%, man. Because there are only two coaches.
40%.
Yes, there are only two coaches.
Two
So
coaches, correct.
yes, so 1 minus 0.6 becomes 0.4, makes up to 40%.
40%.
So 40% chances are there, and even it is written in front of you in the tree diagram, that Alex becomes the coach 4 times out of 10, Sam becomes the coach 6 times out of 10. Great. Sooner they become the coach. Now the question comes that whether you will be selected for a goalkeeper or no. So the probability is written in front of you. So you get Sam. There is a 50% probability. Now the tree diagram starts. So here the tree diagram starts with 60% probability that Sam comes, 40% probability Alex comes. You become the goalkeeper is the 50% probability. You do not become the goalkeeper is again a 50% probability. This is one tree diagram. Let me take it here. Another tree diagram says if you get Alex. So this was the diagram that if you get Sam, mind it, this was the one scenario. This is another scenario that you get the Alex. There is a 30% probability that you be the goalie. So when Alex is there, 40% is the probability that Alex be there. 30% is the probability that you become the goalie or you become the goalkeeper. And this is the tree diagram. Hope this tree diagram is understood well. Yes or no? So we say this tree diagram is complete. Now calculate the overall probability. So your probability is set that here is how to do it for the Sam. If yes branch is there, mind it, yes branch. So we say, okay, Sam has come and you become the goalkeeper. So what is the probability? What are the chances? So 60% chances that the Sam come, you become the goalkeeper, 50% chances. So you multiply them, and only 30% chances that you become the goalkeeper. When you take 0.6 chance as a Sam as a coach, 50% chance that you become the goalkeeper. So you are end up with 30% chances that you become the goalkeeper. But we are not done yet. We haven't included the Alex in our calculation. So with the Alex, I will take this as a probability. With the Sam, I had taken this as a probability. So these two probabilities are of yes, that you become the goalkeeper. So 30% with Sam, 12% with Alex. So in total, you may say that you have 30% probability with Sam, 12% probability with Alex. You have the 42% of the probability that you become the goalkeeper today. Is this understood?
Yeah.
See, I understand this was a very quick and rapid session, at least for the last question. So try to digest it by your pace. I'll be sharing it by today and you will be getting it. And please have a look to it. So this is for our today's session. Let's come for the nice picture photograph. All of you, please be on your mark. You may please come to your camera such that we can take our picture. Sanesh, you didn't participate today. All
I
well?
am trying, but I couldn't come.
Okay, okay. You are trying, but you couldn't come. Okay, Sobinji, all well. Fazil is
I think
traveling.
my photo only come.
Okay,
I'm also traveling right now.
okay. It's all right. It's all right. Okay, let's be at your thumbs up. Great, beautiful faces. Okay, man. All the very best. Hope I would have added value to your life today.
Thank
And
you.
please make a revision. Probability
Okay.
needs a revision.
Mm.
Wear these glasses, look the life, and life becomes easy. Okay?
Yeah.
Yes, it is, if you try. So we
Yes,
are going to meet again by our next thing, and hopefully I'll be dealing with now not the probabilities, because probability is done with good amount of understanding. Now I'll be dealing with the application part, directly including the data science stuff. Okay, will
Okay,
it be
okay.
fine?
Yes, yes.
Okay,
yes, yes, yes.
okay. Now Sanesh got the life. Okay,
Okay.
chalo. We'll meet. Take
Thank you.
care. Bye bye.
Okay,
Bye
okay.
bye. Enjoy.
See you.
Bye.
Thank you. Bye.
Thank you.
Thank you. Orange. Orama.